So now we've got this little handy setup for ourselves made here where we can make a rock. A rock wall. Let's just do something a little bit more MoGraphy with it. I'm going to let's go back up to the top here and feed this some different geometry, and then we'll animate something that looks kind of cool. So what I'm going to do is let's do this to a head, and I don't have a head, so I'm going to just grab a head from our test geometry called Tommy. So let's hit the tab key and start typing Tommy and hit enter. And we got our test geometry called Tommy here. I'm just going to hit the display flag here and focus in on him. Tommy's got a head. Let's just grab that one. Should work. So what I'm going to do is I'm going to go to my selection tool. I've got my select primitives mode selected. And then I'm going to just go somewhere down here around his neck. And I'm going to middle mouse click. I'm going to middle mouse click his holding Shift A. I'm going to middle mouse click this square and then move one square over, and holding Shift A, I'm going to middle mouse click again, and that selects an edge loop. That just helps us determine where our edge loop actually is going to be. And then I'm going to hit the delete key, and that throws down a blast for us. It sets the group to those polygons and just deletes them for us. Now what I can do is I can use my selection tool, and like we did before where we selected 3D connected geometry, you can see inside his head he's got like an eyes and tongue and all that stuff. I don't really want that. But what I did do by blasting this loop of polys away is I created two separate pieces of geometry. Now I can just go and say select 3D connected geometry, and I can actually select between his head and his torso. If I was back up on his if I go back to his original geometry, if I'm selecting 3D connected geometry, it's just the whole piece. So back here, I'm just going to select the head, and I'm going to hit tab and then type blast one more time and hit enter, and that blasts away the head over here in our network. And now what I can do is just click delete non-selected, and that inverts from deleting the head to deleting everything but the head. So now we've got our head here. I just want to fill in these holes around the eyes and the mouth, because if you're doing any volume modeling, you got to have airtight geometry, generally speaking. So let's just throw down a polyfill, and we're going to wire this in here. And polyfill by default is doing some weird thing down here. I'm just going to turn on smooth wire shaded so I can see what the geometry looks like. You can see it's trying to build quads down here and inside the eye holes. I mean, it works fairly well over here, but the neck is looking kind of gnarly. So I'm just going to select a triangle fan. And we don't really need great geo for right now, but that's kind of funny. He actually looks like he's sticking out his tongue and has spike eyes and a spike neck. Cool. By default, it tries to deform that patch. You can dial that back or just untick deform patch, and it just sort of does its best to close it off straight. I'm not really concerned with having too high fidelity of a mesh here. In fact, I want to kind of reduce this a little bit so that it makes our Voronoi run a little bit faster. So what I'm going to do is throw down a poly reduce. Poly reduce here and wire in that and just bring down the percentage to keep. I'm going to bring that I'm just going to slide it down until I get a low poly enough thing that still looks like a face, but it's not so low poly that it's like offensively hard to tell what it is. I mean, that looks like it's pretty good. So we're doing something like let's go for a solid 15% of the original polys, and so that should make our Voronoi run a little bit faster when we do this. So now I can let's just take our curve and this resample, and I'm gonna let's just grab all these guys. What I could do here is I could actually throw on a switch if I wanted to, switch between those two. I'm gonna switch with grabbing all this line sweep base wall geometry creating business over here. Just going to drag that off to the side. Again, this was our base geometry for our wall. I'm going to throw down a switch so we can switch between the base geometry and some other input geometry. So wiring those two in, I can select input 1 to grab this geometry, or I could just hit Shift R to reverse those inputs again so that left is on the left and right is on the right. Cool. So now our head, now our head is going through to our base shape. Now, if you notice, you may have caught this already, but our head is way off compared to our base shape of the wall that we were using. So therefore, I mean, he's almost the size of one rock. So this is almost not going to work in terms of the resolution of our VDBs, that we are doing down here in this loop. So preemptively, I'm going to just prep this head to be roughly in the same size of this this original wall shape that we had. So let's throw it on a transform. And I could sit here and just kind of scale this thing up, but he's going to scale off into the distance vertically if I just use this uniform scale like so. So what I'm going to do is I'm just going to recall our old friendly centroid function that I described in the expressions lesson. So if I want to move this head and center it onto the origin, I just need to move it in the opposite direction of wherever the center of this head actually is. So if I go to my translate here and type in I'm going to lowercase centroid. Actually, let me just let's go. Let me just right click. I'm going to say right click and edit expression just to get this out here so it's a little bit easier to view. I can go here where it says 0 and say we'll type centroid, and then I'm going to choose the first input, so whatever geometry is incoming to this transform node. By typing 0 in this first parameter, it's going to grab that, and then I'm going to say I want to grab the x dimension because we're working with the x dimension. So centroid, open parentheses, 0 comma d underscore x, apply and accept. And you can see that it has created that here. Again, if you wanted help with this, if you're in the middle of editing the centroid function, or an expression here, it's gonna start typing centroid, and it's gonna give you a bunch of clues here as to what you can do. And your d underscore x, y, or z, those are all appearing there just as a little helper. And so now all I got to do is just copy this, and I copy it into the y position. I'm gonna hit paste. And then where this is an X, I'm just going to change that to a Y, and then copy it again and paste it. And where this is a Y, I'm going to change it to a Z. So now it's been moved, but it's been moved up because we haven't negated the we haven't moved it away from the we haven't moved it in the opposite direction of a centroid. We've moved it in the actual direction of the centroid. So we just need minus signs in front of all these. So let's just put a minus sign in front of this one. I'm going to hit tab, and then key to the left, minus sign, tab, key to the left, minus sign, enter. And now it has it hasn't moved our head to the centroid because I still have a scale on here. Now this is, I could fix this by setting this scale back to 1 and then throwing down another transform, or you could change the order in which it's doing these transforms. For example, if I'm scaling this up, I could just say, if you look at the transform order, it's doing scaling first, then rotation, and then translation. I could reverse this and say, I want you to actually do the translation that I just said to do here, and then scale it after. So I'm just going to select the last one in this option. Translate first, then rotate, which we're not worried about, and then scale. So now it's moved it to the centroid, and now I can just scale it. So now I've got my head roughly the size of the wall that we were working on. Awesome. So I'm going to turn off the template flag over here, and let's just see what we get right off the bat with our Voronoi. Cool. So I've it's wiring into the Voronoi like so, and then I'm just going to hit my exploded view to just kind of preview what these shapes look like. If I increase the uniform scale, you can see that it looks like a bunch of shards around the outside pointing inward to the center, which worked for our other example, but for this one, I really do kind of want some, non-uniform scattering throughout the center of his head. So I'm just going to turn the ISO offset back on, which will scatter points throughout the object instead of just on the surface of the object. And when that's used to fracture the geometry, it should look a little bit more interesting for this particular use case. So let's just untick this bypass here, and you get more uniform sizes like that. Now, all these sizes are pretty much the same. I'm thinking I would like to do something that is a little bit, I want these to be a little bit more random. So back in our scatter, where it was trying to relax the points and keep them sort of even distances apart, you can change these relax iterations to be smaller. I'm just going to turn it off right now and see what that gives us in our exploded view. Yeah, we get a little bit more randomness. I think in general these pieces are too small, so I'm actually going to just scatter less of them. Let's just cut this in half and do 75 pieces. And we get something like that. Maybe let's even go down to like 60 and see if we can get even more variation. I'm just going to grab this slider until I get down to something like, yeah, maybe 30. Let's go with 30 for right now and see where we land with that. So going back to our Voronoi here, you can see that it's still giving me these color coordinated pieces because I've got this select connectivity option selected. I'm going to just untick that. I want to go back up to our geometry, and I'm not really interested in seeing its textures. So I'm just going to select the test geometry and turn off the textures. So we just get a grayscale head. Let's go back down here and yeah, cool. So now I'm just looking at the exploded view. Okay, cool. Let's just bring this back down. Let's just bring this back in a little bit just to help visualize. So yeah, we've got some interesting chunks here. It looks like there's some tinier chunks here in the middle of his face. He's got a big one over here. That's cool. Now, like, what if I wanted to animate something like this and just get some interesting motion across these? Let me just turn off the wire shade. I'm just going to switch to smooth shaded just so I can look at these cracks that have been made. I'm going to add a little bit of animation to our scatter points just so we can get some variation and have these Voronoi cells kind of morphing around. So let's do that by adding a jitter. So point jitter will allow you to kind of displace your original points. So if I go over here, you can see I've got a scale. I can like modify that scale, and those points are just kind of moving around. Depending on how much I scale this up, they're just moving in a random direction. So what I'm going to do is I'm going to, let's see here. I want to add like a little expression just to get it to do a little bit of animation. What I found worked pretty good for me in previous run through of this was I'm going to use a value of like 0.1. So it's only scaling it just a little bit, but I want to animate each one of these axes scales just a little bit. So I'm going to just use a very simple implementation of some old trig stuff from high school. I'm just going to use sine and cosine functions to get some circular movement. So along the X, if I do sine of the frame, then as we go along you can see that it's all these pieces are kind of drifting back and forth a little bit. Based off of, just a regular sine function. If I scale this up, you can see it's a little bit more obvious. We're just oscillating to one side and then to the other based off of a periodic sine function, like so. I'm going to do, if I do a cosine function, now a cosine is sort of the complement to the sine. I'll just do cosine of at frame. So it's basically saying every frame reevaluate this. So now we've got these guys, all these little points are moving sort of in different, they're kind of orbiting around in different directions. Cool. And then just to add a little bit to the randomness, if you look down the z-axis, they're more or less just going up and down. I'm just going to add a little bit more movement here by adding another sine at frame. And then maybe I'll just make this one oscillate a little bit faster and say sine frame times 2. That just makes things move a little bit faster in that direction. So now we've got all of our points kind of doing this kind of random motion. I'm going to just, for the purposes, let's just see what we've got in our exploded view. And you can see that now as those points are moving around, it's reconfiguring how these Voronoi cells are being computed. I was going with a smaller value initially, but maybe I'll just go with this for right now. This is feeling kind of cool. This is fun. We've got lots of movement there. Sweet. So now, without feeding this animation through our network just yet, I'm going to go back. Let's go back to frame 1 and just keep it there for right now. I'm going to go to the end of this for each node. You can see it's cooking through our loops, and we'll just kind of see what our rocks are looking like. And right now, I wouldn't even really call these rocks at this point. In fact, I don't even want to do anything with the noise pattern, so I'm going to just disable the mountain. And then I'm going to dial in the shapes of our cells a little bit by doing what we did earlier, which was let's just focus on one at a time. So I'm going to tick on single pass. And yeah, let's just start with this. Looks like it's right around the eye socket. So let's just mess with that one a little bit. So I'm going to maybe just smooth this out a little bit more than we already have. So now our voxel size, maybe we can get by with a smaller voxel size. I'm going to just bring this up to 0.1. That's too small. But maybe with some less smoothing maybe with some lower smoothing settings, we can get a little bit better. Maybe something like that. Now I don't know if that's any different from what we had before. So maybe just bring that back. Bring this one. Yeah, let's just start with that for right now. I'm not sure if that's any different from what we had before, but at least it's more efficient because we're not using so many voxels. And let's just turn off single pass and see what that looks like. Thanks for those nodes. Yeah, that's cool. I think what I would do is I'm going to actually use the reshape now, just to shrink the space between these rocks a little bit. So remember we use this reshape to dilate these pieces. I'm just going to select erode, the erode option, and I'm just going to tick it on. So now it's eroding by 1 voxel. It's going to shrink all those shapes in just a little bit. And looking at this, I'm thinking maybe I'll go with just a tad more Voronoi cells. So let's just turn this total count up to 70 maybe. And it's going to cook through the loop. And there, that's looking cool. Yeah, so you get a little bit of definition of the nose. You can still kind of tell that it's a head. And you've got all these sort of random sized pieces in there, which is cool. Yeah, I'm looking at this. Let's just smooth this just a little bit more. I'm going to increase the filter voxel radius to 3. Let's see what that does. Yeah, that looks good. Just something a little bit more round. So now if I was to go back and try and play this animation, it's going to have to cook through this loop every single time. And that can take quite a while. If I open up my performance monitor here, you can see I've got all these cores that are working. And let's just advance 1 frame and see what happens. Whoops. So you can see it's thinking. All of my cores are jumping up. And then it's advancing to the next frame. Now, there are a lot of functions inside of here that are multi-threaded, especially concerning VDBs. But there's an additional trick that we can do to get this to run even faster, and that's using a compiled block. A compiled block is just like a for each loop, except what's inside of the for each, inside of this new compiled block. Let me just throw it down. Hit tab and type compiled block. What is happening inside of this yellow blob is that everything inside of here is going to be it's going to be precompiled, and then it can be multi-threaded. So I'm going to just turn on manual mode because I've found that I can introduce some crashy behavior if I'm just dragging these nodes on here like so. So I'm in manual mode. I'm just going to drag this to encapsulate my for each loop. And then if you go to your block end node of your for each loop and turn on multi-thread when compiled, and then turn auto update back on, And let's just select our compile end node and hit force compile. And now if I were to advance forward one frame, it goes much faster. It's not super fast, but it is a whole lot faster than before when we were watching our individual loop. So if I click play, we're going at about, you can see 11, 12, 13, 14, 15. That's how fast it's computing this for each loop for us. And if I stop that, and I'm just going to select the for each end and put the display flag there, you can see it cooking through this loop, and we'll hit play on this one, and you can see how much slower it is. So let's hit play. Frame 21, 22, 23, 24. So you can see it's going much faster, even if only a little bit. Every little bit helps when you're dealing with stuff like this, and especially when you get into like larger and larger scenes. It's going to be really helpful to be making sure that you're multi-threading as many things as you can. So I hit play. 26, 27, 28, 29, 30. Cool. So this is processing really fast now, which is great. And likewise, what it should be doing is doing something cool with our grout. So let's go see what we've got for grout just off the bat. As our VB combine, let's go down to here, and I'm not going to want this mountain. So here we've got our grout, which isn't really grout at this point. I don't know what it is, but it's looking interesting. So I'm going to turn this mountain off and just see what we've got. Yeah, so this is looking okay. So over here, we're still doing a pretty high res. Up here, I'd set this to 0.01. I'm going to just go down here and set this guy to 0.01 as well, just so we get a little bit lower res. Yeah, so we start to get some like more interesting behavior when we start to smooth it out. Yeah, this is looking nice and spiny or something. I don't really even know, but let's go to in the VDB combine. We've got this smooth going on. I want to just see what dialing around different settings of this will do. So if I turn the iterations to something like 4 and then convert that back, yeah, we get some nice like branchy looking structures in here, which is cool. I think that honestly, it honestly is a little bit jagged for my liking around these edges here, so I might crank up this voxel size a little bit. I might just crank this back down to 0.005 to get something a little bit more high res once we end up converting it back. And to compensate for that in the smooth, I'm going to have to do some larger voxel radius is all. So if I increase this voxel radius to, let's say, something like 3, we get this nice kind of almost like cellular skeletal looking structure inside of here. And then when I convert that back, we get some pretty clean looking geo, at least for this like kind of organic looking behavior, which is cool. And so now if I combine these two together, I get sort of this like kind of, brainy, well, honestly I don't really even know what this is, but it's a sort of distorted, interesting looking structure. If I hit playback, it's pretty slow at this point. And so this is, whenever I run into issues where playing back from frame to frame gets really slow like this is where I start to do a cache. So let's do one so that we can get more of a satisfying playback of our geo here. So before I do that, I want to just, to make it easier for me, I just hit escape. I'm just going to stop that from cooking. I think that the for each loop is probably taking a lot of time. I want my rocks and my grout both to be cached, but I might want to, I'm not quite sure I even want the rocks in my final setup or not. So I'm just going to create 2 groups. I'm going to make a group for the rocks just so that we can so that we can separate our rocks out later on. So I'm just going to go up here above the rocks. I'm just going to shake this one off. I'm going to pipe this in right before our rocks null. So that way anything that goes into the rocks null, we know it's got the rocks group. So under this group, I'm just going to select rocks. And I'm going to type in rocks into the group name, and it's going to group primitives. and it should have created a group for us. If I turn on this display flag, there isn't really a way for me to tell. If I middle mouse click, you can see that I've got prim group, rocks, 360,000 polys in there. Cool. Let's just do the same over here for grout. I'm just going to option drag this group down here and pump it in there, and then we're going to call this grout. And if I middle mouse click here, you can see I've got a prim group called grout, and it's got 962,000 polys in it. Cool. And then at the end here, if I do a split, just to double check, if I split off my grout group, yeah, it isolates our geo for us. So splitting the grout with the rocks. So I've got rocks by themselves, and I've got grout by itself. So I'm just going to take this split out of here because I don't need it. But now that I've merged this geo together, I can call this my merged geo. And I can go, let's go and throw down, let's cache this out to the disk. So let's choose a frame. I don't really need 1,000 frames. Let's just do maybe 240 frames, just like 10 seconds. So I'm gonna my project I'd set to 1,000 earlier when I was trying to just see, you know, how long these things would go. I'm gonna go to my settings button down here. I'm gonna select my end. I want my end to be, let's just do 120 frames. So a little 5 seconds. We'll hit apply. Close that off. So I've got my merged geo. So the next thing I want to do is I want to throw down a file cache. So I can hit tab here, type file cache, and it brings up this file cache node. And what I'm going to do is wire this in here, and I'm going to name this my wall head. Let's just call it wall head. I don't need to use my in there. So we're going to call this wall head because I can't think of anything else to call it at this point. And you can see, if you look at this file cache node, what's going on here? This geometry file is, you know, by default pointing to a certain location. Now, this is similar to what we went over in the rendering section. So $hip, what it's going to do by default here, if I click this button, is it's going to $hip / geo / and then writing out a list of files. This $hip, the directory is inaccessible because it hasn't been created yet. But it will create the intermediate directories for us if they don't already exist. And you can see that option over here. Now, if I were to go to, remember the job variables that we set up before? If I go to $hip is inside, if I go up a folder, we're in our scenes folder. Our project folder is in the scenes folder, but I want to store my cache info in a cache folder. So if I go to my $job, I go to $job here, I can create like a new path inside $job. So I'm going to just do that, but instead of doing it through this chooser, I'm going to actually just do it out here. So instead of $hip, I'm just going to type in $job. Then I'm going to, instead of creating a geo directory, I'll just call this cache. And then at the end of that, I'll use this same naming convention that they use. $hip name, which is the name of the project that we're in. It's going to create a file with the name of the project that we're in, and it's going to say $os, which is the name of the operator that we're on, which is the wall head. And then $F, which is the frame, .bgeo.sc. And .bgeo.sc is just a geometry format that is super efficient and compressed for Houdini to store geometry, and it can store all the information all the information on the geometry that is needed for Houdini to understand it and use it further on down the line, such as attributes and all sorts of things like that. So you usually want to stick to .bgeo.sc, but in our case, since I'm doing a project and I don't know how many caches I want to write, I don't want to just write this list of files out into our cache directory by itself. So if I middle mouse click here, you can, on the geometry file, you can see where it's evaluating. So I'm just toggling back and forth using the middle mouse key. You can see it's going to the tutorials folder, lesson 3D, cache, and then lesson 3D SOPs version 1.wallhead.1.bgo.sc. I could just put them all out there in the cache folder, but I just want to make one more folder to denote what this actually is. And I'm going to make a folder that is, so that when we're navigating through Windows Explorer, we can see, oh, I want my wallhead caches. Where are all my wallhead caches? So to get that, I'm just going to type in $OS. $OS is going to create a directory called wallhead. And then I want to do another directory based off of the name of the file that we're on. So I'm going to do $OS / $hip name. So I like to use the hip name to version through my caches, and instead of using like a specific version number that I set manually, using $hip name allows you to basically record a paper trail of the file that created it. Because my file name is lesson 03D SOPs version 1, I know that if I ever need to get back to it or use this cache as a starting point, or the file that created this cache, I need to tweak something with it, I know exactly what file name was that created it. So now if I look at my my file path, you can see that under my cache section, I've got a wallhead cache. I can have multiple versions of the wallhead in here. And then I've got the version of that cache denoted by the actual file name. And then I've got, just a long string of all that information slapped together for each cache. And, we're really not going to have to necessarily look at these, but it's just important to note where you're writing them out. So with that, I'm going to just hit save disk. And you can see it's automatically grabbed my frame range from 1 to 120, and now it's writing stuff out. And you can't see. Usually, what it does is it pops up this thing. Okay, so for whatever reason, this didn't pop up right away, but this is what's going to be giving me my progress as to what all it's doing. Now, if I go over to my project file here under lesson 03D. And sometimes while Houdini's writing out caches, Windows seems to like to do the blue spinny thing, but you can see it's created my cache folder. If I double click in there, it's got my wallhead. Double click in there, it shows my hip name folder. And if I pop in here, you can see that here are all the cache files it's writing out. If I just make this window a little bit larger, you can see it just populating this directory. So I'm going to pause the recording. I'm going to let this do its thing, and then I will be right back. The cache just finished up. It looks like it took from when I started this at about 6:21, and it went until about 6:27. So it took about 6 minutes to cache out. Cool. So now back over here in our Houdini scene, if I were to click play, nothing has improved. It's not going any faster, and you can see down here in the lower left-hand corner that it's cooking every frame. That's just because by default our file cache isn't reading anything off the disk. So I just got to go up here and tick this box that says load from disk, and now when I hit play, it is loading everything much faster. It's not like, still it's not real time. So there's still something to be desired there. But what I could do is, for now, I've got my separate groups, and I just want to focus on maybe previewing what the grout group looks like. So let's just grab the grout group like in our split. So I've got a split with grout entered into the group. So we're just looking at the grout group. And because it's loading this off of the disk, it's really dependent upon how high res your geometry is and how how quick your disk speed is. I've got a spinning disk that this is on currently, and so you can see it's playing back fairly a fair bit quicker. But it's not amazing. So this is sort of where Flipbook comes into play. So I'm gonna just let's just flip to our grout section right here, and let's just do a Flipbook. So down here in the lower left hand corner is a Flipbook with new settings. So it looks like a Flipbook. Just hold down on it and then say Flipbook with new settings and lift up your mouse. And so here it's got my frame range from start to end. That's cool. Under my size, I'm going to just set the I'm just going to untick setting the resolution, and I'm unticking crop out view mask overlay. That basically would say, like, if I had a camera in the scene, it would crop it to the dimensions of that camera and crop out the mask that was applied to areas that weren't rendering. I just want to render out the square of this image. So I'm going to just, I got this set up. I'm just going to hit, now that I've unticked those two things, we're just going to hit start. And what it'll do is it'll start playing back through the timeline. It sometimes like hangs for the first couple of seconds. This happens as it's opening mplay, which is, if you remember from the rendering lesson, just a separate, kind of picture viewer like looking thing that allows us to play back our sequences in real time, just like a hardware preview. So I'm gonna let this go for however long that takes, and I will be right back. Now that flipbook is finished, and apparently RF end was set to 240 down here. So I'm going to just, you can see my slider down at the bottom. I don't actually have 240 frames. It just goes beyond that. So if that ever happens to you, you can just set your endpoint at the end to 120, and then you can get a nice view. So I'm just going to go back to frame 1, hit play. And you can see this is what we've created. We've got like, it sort of looks like this really gnarly, disease that is occurring with this guy. And I know that like a lot of this now with new fields and new volume builder tools in Cinema 4D, you could probably get around and create something just like this. But I just thought, it's important to know how to do this stuff in Houdini, and it's really kind of it's really kind of, cool to see that workflow. I think that honestly, from a flexibility standpoint, you get a little bit more power when trying to set up things like this in Houdini, especially when you want to go back and, jump up to the top of your tree and reset and build this out of some completely different geometry. It feels more flexible to me, but then again, that's what I'm used to. So it could go either way, I suppose. At any rate, so now from here, what you could do is you could maybe, if you wanted to bring in, your original head that you grabbed up here, I'm just going to add a little null for myself here. This is going to be the high poly. Oops, sorry, I got to type in null before I can name it. So let's type in null, drop that in here, and just going to call this a high poly head. And then if I just, I'm going to option click over here. I'm going to option click, I'm option clicking on the output of this node, option clicking over here to create another knot. And I'm just going to wire this all the way down here. And then I'm just going to option click right here and then hit tab merge. So now we're wiring in our high poly head down here. I'm not seeing anything because you know what? We did a transformation of this down here after we did the poly reduce. So now this is where it's smart to maybe if I wanted to access this later, I would have actually transformed this before reducing the polygons. But since I've already done this, and I could move this back, but I don't want to mess up this network at all by changing what I've done here, I could do something like create a reference copy. And so I've got my transform here, which I've changed. I could create another transform that does this exact same thing. I could just copy, I could right click here, copy the parameters, and in this, like if I made another transform here, and wired it in right here, I could simply go over here, right click, copy parameter over here and translate, and then paste relative reference. And I could do this for every single field that I had modified on this node, for which in this case isn't that much. I just, did centroid translation and then, scaled it up uniformly. But a cool little feature that comes up quite a bit in my workflow is I could do, I could automatically have a node be created for me that will automatically mirror whatever this node is doing. So if I right click here, go to actions, and then say create a reference copy, you can now see that this has a little comment, says reference from transform one, and then literally every single parameter. The transform order has been updated according to this object, as well as it's brought in all these values from this original transform that we did. So if I just wire that in over here, and it looks like it was trying to wire on its own. I'm just going to hold Y to unwire that extra wire that was there. So if you hold down Y and just drag through that, it'll disconnect it, which is what I did. And so now you can see that if I go up here, select my low poly geo, go over here, and see my high poly geo, those are both being transformed into the exact same location because this transform is a reference of this transform. Cool. So now that I'm bringing down the correct position for my head all the way to the bottom here, I could, also, wire in this this other geometry of the grout which is inside it. But I can't really see that. Maybe what I'll do is I will I'm going to throw down a attribute create. And just because I know that this is an attribute that exists and works with our viewport, I can go up here in our name and I can type in capital alpha. If I hit enter, by default, it sets the alpha to 0, and then we can kind of see through it. Alpha is just like any other attribute, which we'll get into in a later lesson, but essentially it's recognized by the viewport as transparency. So you start to get these transparent looking effects. If I turn on smooth shaded, you can see we get sort of an outline here. It's a point attribute. The value by default is being set to this first amount. So I can actually dial in and out the transparency on this alpha by just middle mouse dragging on this. So, suppose I wanted to have this be some disease that was inside this object and I merge these two together, you can see that I can kind of see through it. So let's just dial this alpha back until I get to a level that I'm liking. And the other thing you can see here is that I'm having a hard time seeing what's going on inside this head. And that's probably due to the fact that after we merge these together, sometimes the normals get mixed up. So I'm just going to throw down a normal after the merge. You can see it's giving us an error here saying that there's a mismatch of attributes because there isn't an alpha over here, but there is on this one. And so that can sometimes get you mixed up. It looks like it's actually trying to copy the alpha from this left-hand stream into the right-hand one. I'm going to just, what I'm going to do to remedy that is I'm going to just duplicate this alpha, and I'm going to put it over here underneath this stream, and I'm going to set it to 1. So now we've got our semi-transparent head with this disease inside of it, this diseased-looking or I don't know what you want to call it, but just sort of this like skeletal structure happening inside of it. Maybe if I increase this alpha value to something like 0.5, we can get a better idea of like some crazy subsurfacey type of semi-transparent render that we could do where we've got our head on the outside, but then like this crazy structure just kind of gnarling along on the inside of it. Something cool like that. So like maybe other things that we could do after the fact is, we've got this, we've also got these Voronoi cells. I mean, I could wire those into the merge as well. You can see that those are also transparent. If I just drag this alpha attribute over here onto this one, you can see the cells in combination with the skin. But like, suppose I wanted to resize these cells to make them all a little bit smaller so that they kind of float inside of the inside of this like mesh that's been created. I'm going to just option drag this merge over here so I can just split off and look at the cells by themselves over here. So I'm just going to hit the Y key and just make it so that the original head isn't being merged in. And you can see I've got these cells. So let's just throw down another for each loop. Because what I could do is I could throw down a transform if I wanted to. And if I wanted to change the size of these cells and just highlight, the cells going in, if I were to scale this down at all, it's just scaling the head completely as a whole, all of those different cells. But if I were to set the translation location to the centroid, like we do, centroid 0D_X, like we've done before. So that's just going to actually not the translate. I want the pivot to be located in the centroid. So I'm going to go centroid 0 for the first incoming geometry, 0D_X, and then I'm going to hit Control A, copy, Control C, hit Tab, Control V, paste that, change this to Y, and then hit Tab, paste that, change this to Z. Now the centroid has been moved to the center of this object, which is still 0 because we haven't done our for each loop. So let's just do our for each connected piece one more time. For each connected piece, we want to loop over it and transform it by its centroid. So now if I were to scale each one of these pieces, it's going through the loop, finding the centroid of each piece, because of this expression, is dynamically reevaluating every time we go through the loop. And then we can, do more work on each individual piece after the fact. Like we've already cached this out, and now we can continue to post-process this to our liking. So I could say I want these all to be, 50% of the size, or even, maybe 25% of the size. So all these are just little nuggets in the middle here. And then merge that back with the original structures, and you see you get these little chunks, is sort of representing where the center of these cells are. And if I play it back, you can, or scrub around, you can kind of see how they move about. It's sort of hard to see at this point. Maybe I'll bring these up to 0.5, or just something that's a little bit offset to make it a little bit more interesting. Maybe even, I don't know, 0.7. Yeah, something like that. So really you kind of get these interesting structures. So, that you can change after the fact using these for each loops. So you could do all sorts of crazy renderings and stuff like that with this type of an object. And, we'll get more into, exporting something like this into Cinema 4D later. But, in the meantime, this is sort of in demonstration of what the possibilities actually are when you combine all of these different ideas together to create something. And we haven't even simulated anything. This is all just in SOPs using expressions and caching and volume modeling and looping. So I know we covered quite a bit in this lesson, but really I think that it's cool to finally get into a more in-depth example. I know that up to this point we've really been covering a lot of sort of abstract and dry concepts as we look at how all these individual elements work. I felt like going forward with some of these more advanced concepts, it would be better to sort of bring them all in this example that is relatively simple, so to speak, but it actually covers a lot. We've got for each loops here. We did a compiled block. I mean, that's a relatively advanced concept, but an amazing way that you can speed up your workflow as long as you've got, the correct settings going on inside of here. We did a little bit of Voronoi fracture, some procedural modeling stuff. We managed to cover some more of our basics procedural modeling nodes like the sweep and whatnot. Polyreduce, we did some of that. What an ISO offset is, point jitter. We covered some functions with that. And just, sort of what a standard workflow looks like. Really all of our examples have been pretty tiny up to this point, but, we just, built a network that looks like this. I mean, and, we're getting an end result that's kind of cool, and this really wasn't that difficult. And if we honestly had to, we could just go back through the top, work our way down, look at all the steps, see what we entered in everywhere, and see how everything that we've done that if you just go node by node, it's really not that complicated. Then at the end of it, you can just zoom out and look at this amazing network you created, and you got this final product that you're happy with, and you can send this off to render. So I hope that you guys thought that was fun and in gals, and I think that in the next lesson, what we're going to do is we're going to look at a little bit of how to build digital assets. So, suppose if you had this thing that you created and wanted to generate an asset that could, basically take in any input and do this to it, you could do that. We're not going to build a digital asset out of this particular setup. We're going to build something a little bit simpler just to make it a little bit easier to wrap our heads around the power of the digital asset. But you could easily take any setup like this and turn it into some reusable tool that you could access through your tab menu. So we'll get into that in the next lesson. In the meantime, I hope that this was fun, and I'll catch you later.